Hello, ladies and gentlemen, this is Mrs. G. I'm going to do my best to give you guys a bit of an explanation of what I'm looking for in kind of the extension or 7-8 level. Sorry, excuse me. A question when it comes to this assessment on maximizing the area given a restricted perimeter. So what I want you guys to do here is basically this idea of, take a pattern that you've noticed and extend it to a new situation. Okay, so this assessment is all about quadrilaterals. You have 4 stakes, and you're hopefully noticing what happens to the area as you change the kind of type of quadrilateral that you're creating, right? Okay, where are you putting those 4 stakes? What do you notice as you move things around? I don't want to tell you guys the answer. So now for the 7-8 level, what you need to do is go beyond just quadrilaterals. Maybe you want to try triangles. Maybe you want to try pentagons. Okay, how is the pattern that you observed here, how might that extend to a new shape? Is it the same thing or is it not the same thing? Okay, basically make sure also remember that this is only about question 1, the 7-8 level. Okay, so how are you going to stake out your plot of land given your 4 stakes? What kind of shape? Basically, what kind of shape gives you the maximum area. Okay, so don't worry about these 2 when it comes to the extending your pattern, unless you really want to. I mean, that could be an extra exciting part or an extra bit of work with the extension. Okay, is your shape, if you try a triangle or a pentagon, how might it work in these situations? But that's not really the main focus I want you guys to have. The main focus I want you to have is, how do you plot out a shape if you want to maximize the area and not just a quadrilateral, but any shape. Okay, you might want to start with triangles. Okay, it's up to you, but that seems to be the most simple idea. You have to remember that the area for a triangle is a little more complicated, base times height divided by 2. Okay, it's not as nice as a square, which you're just doing the area is, length times width or base times height, depending on how you like to think about it. When it comes to triangle, now we have this different situation where we have to use the base times the height. And what's really important to understand is that the base and the height absolutely have to be perpendicular to one another. That's how you figure out, what is the height and what is the base. You have to have a situation where you have a 90-degree angle in between the height and the base. Okay, so for something very simple here, I'm just kind of jotting out a few little examples. In this situation, you would have a triangle with a base of 6 and a height of 4. So area is equal to 4 times 6 divided by 2. That would be 24 divided by 2. So that gives you 12. Okay, the area of a triangle is really fairly simple. And I guess I haven't put a label here, so this will just be units squared because I'm just kind of counting the units on my grid paper. The area of a triangle is really very simple when you're given the height and the base and you're given the fact that they're perpendicular to each other. Okay, what happens in something like this? Okay, I might actually erase these for a second. What if you're given a triangle that looks more like this, where you're not given the exact height that is perpendicular to the base? Well, first of all, draw it in. You draw the height. Draw it as if it is perpendicular here. So I'm going to count my boxes. I have 1, 2, 3, 4 units along the bottom. And this is just a sketch. I'm sorry, it's a little, it's not the most perfect thing. 1, 2, 3, 4, 5. I think you get the idea, though. Okay, so my triangle is 5 units tall, and it's 4 units wide on the base. So same idea. Now that I have that information, area is equal to base times height divided by 2. So area is equal to 4 times 5 over 2. That's going to be 20 divided by 2. So therefore, my area is 10 units in this situation. Okay, now what if someone wanted, maybe, to find the area of an equilateral triangle when you know the sides? Okay, I just made up an example here of 20. So let's say you have an equilateral triangle with 3 sides that are 20 meters, I guess you'd say. Well, the situation here is the height, it's not that you don't have a height, I guess, it hasn't been drawn in yet, and it would be right here. Okay, and you can draw your little right angle to say those are perpendicular. Now, in an equilateral triangle, this doesn't happen with all of them, but with an equilateral triangle, you're going to take this 20, that is the base, and you're going to chop it in half. And you're going to have 10 there, and you're going to have 10 there. So how, this is what makes this difficult, do we find this height? You're going to need some information that's a bit outside of the scope of 7th grade to be taught to everyone, but if you're interested in doing this higher level thing, this is something that you can probably try. So to find the height here, to find the length of this segment right here, you're going to need something called the Pythagorean theorem. Okay, the Pythagorean theorem works with right triangles. And what the Pythagorean theorem says is that a squared plus b squared equals c squared. Okay, this doesn't work for all triangles. It works for right triangles. Okay, and we actually have a right triangle right here. Okay, so pretend as just for a moment, you're focusing on 1/2 of your equilateral triangle, because that will help us find the height here. Okay, so in this right triangle, it's important with the Pythagorean theorem, in general, it says in a right triangle, you're going to have 3 sides. C is what we call the hypotenuse. Don't get too caught up with this vocabulary terms. C is the side of the right triangle that is across from the right angle. It's the longest side of the triangle. A and B, it doesn't really matter which one you call A and B. Conventionally, we usually call A the smaller one and B the larger one, but it really doesn't matter which side we happen to name A and which one we name B. The one that really does matter is the C, and that one's actually fairly easy to figure out where it is. It's just the longest one. It's the one that's across from the right angle. Okay, so my situations here, can you guys maybe help me see which ones are A, B, and C? Well, the easiest thing to notice is the longest side, the side that's across from the right angle. That's what we're going to call C. Okay, 10, let's call that A, just because it seems to be the smaller one. And let's call this one that we're missing B. Okay, so there was a mathematician, his name was Pythagoras, and he came up with the Pythagorean theorem. A squared plus b squared equals c squared. Okay. So if we know that a squared plus b squared equals c squared, let's instead, start plugging in the numbers from this triangle here as it pertains to the formula that might help us figure out the height. Okay, so we were calling this question, right? So let's call C the largest one. We know that, okay? C has to be the side length in a right triangle that is across from the right angle that is the longest length of that triangle. Okay, so instead of writing C, we'll write 20. Now we bring down that exponent of 2 because that's part of the formula. Here, instead of writing the letter A, we'll write down 10. Now we don't know b squared, so we bring that down. Okay, let me show you how this works, and just stick with me, okay? So 10 squared is 100, plus b squared, I don't know that. 20 squared is 400. Now if I want to find what b is equal to, we're going to need some algebra here. Try and solve for b. So subtract 100 on the left side, moving it over to the right side. B squared is equal to 300. Now how do I undo this little exponent of 2? Okay, let's think about what's happening here. What we're really saying is b times b is 300. Okay, you're not going to divide by 2. That's not going to get rid of an exponent of 2. b multiplied by itself is 300. So what number times itself gives you 300? Okay, do you guys know how to go to find what thing times what thing makes a certain amount? The opposite of squaring a number is actually what's called the square root. Okay, it looks like this symbol. Square root of 25 equals 5, because 5 times 5 is 25. Okay, does that make sense? Let me see if I can try that again. So 5 squared is the same as 5 times 5, which is equal to 25. how, mathematically, what symbols do I use to go in this direction? Okay, I have the number 25. I want to know what thing times what thing gives me 25. That's what this square root symbol looks like. Okay, if I was a little bit better drawer, it would look a little bit more like that. Okay, maybe you've seen this before. So what we need to do in our algebraic equation here is find the square root of 300. Okay, so if we write our symbol, the square root of b squared, and the square root of 30. Remember, when it comes to algebra, as long as you do the same thing to both sides, you can do whatever you want. So I took the square root of both sides of my equation. The square root of b squared is b. That's how we're defining a square root. The square root of 300, just put that in your calculator. So you're looking for what number times what number gives you 300. All right. I just popped that in my calculator. I got about 17.3. Okay, so that tells us that the height of my triangle here is 17.3. Now guess what? I still haven't found the area. That's what makes this a little bit more difficult, ladies and gentlemen. Okay, so the area of my triangle is base times height divided by 2. The area is going to be, what is the base? Now remember, we want the area of the whole triangle. Find a different color. We want the area of this whole triangle, because now we're actually going back to what the assessment is asking us, not this long kind of tangent about Pythagorean theorem. So we're trying to find the area of the whole thing now. Okay, because we're hopefully comparing that to other types of triangles. So the base of the entire triangle is, actually somehow it got erased in here, but if we have a 10 and another 10, this was 20. 20 times a height. Okay, the height of the triangle is not 20. Okay, that's not perpendicular to the base. The height of the triangle, which we just did a lot of work to figure out, is 17.3. And I rounded that, ladies and gentlemen. In my calculator, it was 17.3, on and on. Rounding to the nearest tenth is just fine. And we divide that by 2. Okay, so 20 times 17.3. Put it in your calculator. 20 times 17.3 is, 20 times, 20 times 17.3 is 346. Thank you for bearing with me on that. If I divide that by 2, I should get, about 170. So 173 square units. Okay, so that's how you're going to go about, more or less, trying to find the area of an equilateral triangle when you're not given the height, right? You're given the 3 sides, and you have to use something called the Pythagorean theorem to figure out the height of that triangle. Now, I haven't even gotten into other shapes. If you're going to do something like a pentagon, okay, be aware that we don't even have a nice formula like we do for triangle for the area of a pentagon. Okay, for example, a quadrilateral area is base times height. For a triangle, area is base times height divided by 2. We don't have one of these nice little formulas as we get into polygons that have more sides than a quadrilateral. So this becomes even more interesting. What you can do is think about composite figures. If this is your pentagon here, all you'd have to do is think about where the center is and maybe cut it into 5 triangles. If those triangles happen to be the same size, you could just find the area of this one and then multiply it by 5. That would give you the area of the entire pentagon. So once you get into larger figures, you have to think about just kind of cutting them into different size or different shapes that we do have formulas for. Okay, a hexagon, you'd have to cut it into 6 triangles if you find the area of one of those triangles, and it's a regular hexagon, you can just multiply by 6. If it's not a regular hexagon, you'd have to find the area of all the different triangles. Now be aware, luckily for you, Mrs. G has taught you how to use GeoGebra, which maybe has a calculate area function of different types of shapes. Maybe, hint. Okay.